Welcome everyone. Today we are diving into module 1 starting with the clutch. A clutch is a vital mechanism that transits rotary motion from one shaft to second shaft when their axes are coincident. You will find it positioning right between the engine and the gearbox, acting as the gateway to engage or disengage the engine power. Function Function of a clutch. Why do we need a clutch? Primarily, it is allow us to engage or disengage gears while the vehicle is stationary and the engine is still running. It is also ensure that engine power reaches the wheel smoothly, preventing jerks during motion. Finally, it lets us shift gear while moving without damaging the gear wheels themselves. Characteristics of a good clutch. What makes a clutch good? It should be simple to operate and transmit power smoothly without slipping once engaged. It must disengage quickly and accurately, radiate heat well, and remain balanced during rotation. Most importantly, for the owner, it needs a long, trouble free life and should be easy to inspect or repair. Single plate clutch. Let's look at the single plate clutch. Here the friction plate is squeezed between the flywheel and the pressure plate. We using spring arrangements in a clutch to provide the axial force needed to keep the clutch engaged. The friction clutch itself is a mounted on a splendid hub so it can be slide along the gearbox shaft. When the driver pushes the pedal, it pulls the pressure plate back against to spring to disengage the power. This is the figure of single plate clutch. Next one is diaphragm spring type clutch. An alternative is the diaphragm spring type. Instead of many coil springs, we use a single diaphragm spring. The design is more compact and the spring forces are less affected centrifugal force. The diaphragm actually does two jobs. It acts as a clamping spring and a release lever simultaneously. This is the working of diaphragm spring clutch disengaged and engaged. Next one is multiplex clutch. In a heavy transport vehicles, we use multiplex clutches. By increasing the number of friction and metal plates, we increase the torque transmitting capacity. This allows us to have a smaller overall diameter compared to a single plate clutch while handling the same amount of power. One set of plates side on the flywheel while the other side on the hub. This is a figure of multi-plate clutch. This is a dismantled view of multi-plate clutch. Next one is centrifugal clutch. For high-powered engines, pushing a heavy clutch can be fatiguing for the driver. The semi-centrifugal clutch helps too by using both spring forces and centrifugal forces. The spring handle torque at normal speed, but as you speed up, centrifugal force assists in keeping the clutch firmly engaged. The last one is centrifugal clutch. In a fully centrifugal clutch, we eliminate spring entirely and rely purely on centrifugal force for engagement. It is controlled by the accelerator. As engine speed rises above a set point, weights fly out to engage the clutch. This is perfect for simple vehicle like mopeds because the clutch disengages automatically whenever the engine speed drops. The last point is necessity of transmission. Moving on to the transmission, We need it because the resistance to a vehicle motion changes at different speeds. We have to weigh the tractive effort, that is the driving force, parallel to the road to keep the car moving efficiently. Okay, thank you.